Welcome back, guys. Today's question is count primes. So, we will be given an integer n and we are supposed to return the number of prime numbers that are strictly less than n, which means we need to count all the prime numbers that are lying in the range of 1 to number integer n. Now, if we would approach the solution in our naive approach, the time complexity of our solution will be pretty high. It will be n cross square root of n, which is still high when we are given a constraint like 5 cross 10 raised to 6, and it will eventually give us time limit exceed. So there comes the solution Sieve of Eratosthenes. I don't know how it is pronounced. What we are doing is we are keeping a track of all the numbers from 1 to n, and we will be marking initially all those numbers as prime. And now, if you will notice that, let's consider we encounter a number 2. We know that a number 2 is prime, so we would mark all the multiples of 2 which are less than the particular integer n as non-prime, and we would skip those particular non-prime in our next iterations. This would optimize our code a little bit, and we will also be keeping those numbers in our array, boolean array prime. First of all, we will mark all those number as true. We will be considering all those numbers that are prime, and we will be starting our for loop from 2, and we will be iterating till the square root of n. And if we will be only checking, we will be performing our next for loop only if that particular number is prime. And if that particular number is prime, say let's say 2, initially 2 is prime, so we'll be marking all the numbers that are multiples of 2 and less than n, and we will be skipping I plus equals to p, which means we are skipping p times the integers, and we'll be marking all that are false to be a non-prime number, right? Similarly for 3, similarly for 4, but we will notice that 4 is marked as non-prime by 2, so which we will be skipping it, and we will be marking multiples of 5 and multiples of 7. But you will also notice that uh, 2 cross 2, 2 cross 3, 2 cross 4, then 3 cross 2, but 3 cross 2, which means 2 cross 3, is already marked by 2. So we will be skipping all those iteration and we will be starting our second loop with p cross p, not I, right? So we will be optimizing a little bit of our time here. And the second optimization which we could make is iterating our original main outer for loop from p cross p, which means square root of n times. And then at last, when all the particular iterations are over, we will be again traversing all the maintained array from 2 to n, and we will be incrementing our count if that particular bit is prime, and we'll be simply returning our counter. Thank you. Welcome back.